now we can see about the order of an element. Okay, so the order of an element A in a group is the smallest integer n such that A into n equal to E is the order of the cyclic group it generates. In previous classes, we learned about to create the cyclic classes. So here what we are going to do is we are going to find the order of the element. So the first example what we are taking is we are having a group is at 6 and the binary value we are using is addition. So we know that so it's having 6 elements and the binary value is addition. So the elements are 0, 1, 2, 3, 4 and 5. So keep this in your mind. To find a positive integer n, that is it having n into a equal to 0 mod 6. Okay, so this formulas using this expression we are going to find the order n into a, where a represents the elements in the group, elements in a group. That means 0 is the first element, 1. These are all A0, A1, A2 like that. These are all called as A. And N is the order of an group. So considering the first element that is 0, we know that formula N into A which will be equal to 0 is the order. Okay, so N into 0. For all values of n, this value will be equal to 0. So the order will be equal to 1. Now consider the second element. That is, what's the second element? That is 1. This 1. This is the second element. So formula is n into a. Okay. So the second element is 1. So now we want to substitute n here. First I am putting n equal to 1. That is 1 into this a remains same for all this expression. That is for this element 1. 1 into 1. That will be equal to 1. Okay. Then again I am changing the n value. Earlier we used 1. Now the n value will be equal to 2. 2 into 1. That is 2. Similarly again changing 3 into 1. That is 3. So we will halt this iteration when this become 0. For this example, this element, when we are applying n equal to 6, that is 6 into 1, that value will be equal to 0 when applying mod 6. So the order of this element is 6, because when applying n equal to 6, it belongs to 0. So once again I am reminding the condition highlighted here. So n into a which will be equal to 0. Where, at what point this value will be equal to 0, that is the order of the filter. Okay, let's continue this. So now we are considering the second element. What's the next element? That is 2. So n into a. Okay, the a equal to 2. So first applying n equal to 1. 1 into 2 equal to 2. Then applying n equal to 2. 2 into 2. That is 4. Still we not received 0. Then n equal to 3. 3 into 2. That is 6. 3 into 6 means, so we need to this element exceeded the group. So we need to apply the modulus value. So the modulo of 6 is 0. So we are halting. We reached 0. So we are halting this operation. So the value will be order will be equal to the last n value. At what value we reach 0? That is n equal to 3. Similarly, the next element also. The next element is 3. Element 3. What's the element 3? That the value equal to 3. So first n 1 into 3, that is 3. Then we are applying 2 into 3, that is 6. So while applying we are getting 0. So the order is 2. Similarly when applying for the element 4, that is n equal to 4, n into 4, this is the formula we are going to apply. First value 1 into 4, you will get 4, we are not getting 0, so again we are continuing, then applying n equal to 2, 2 into 4, that is equal to 8. So 8 means exceeding the group, so we need to apply mod 6, so the value will be equal to 2. Applying the mod 6, the value you are getting is 2. Then again, already we applied n equal to 2, so now I am going to apply n equal to 3. 3 fours are 12. So again exceeding the group, so we need to apply mod 6, that will be equal to 0, so we are getting 0, so we are halting here, and the n value, the order of this element is 3. Similarly, when applying 5, the same procedure we are following here also, for the fifth element, and you will get the order equal to 6. And I am reminding you, this is the generator. Why this is generator? When applying the order to the fifth element, you will get all the elements in the main group, that is 0, 1, 2, 3, 4 and 5. Okay, so this element is called as generator. That means the elements we are getting the same in the main group. So the order for 0 is 1, 6, 3, 2, 3 and 6. This is the order for this group. This is for addition. So same thing we can go through a multiplication operator also. The same example we saw in the previous lecture. So this is a co-prime number. We know to create this group, the group elements are 1, 3, 7 and 9. Okay, so here we are going to use multiplication operation. Okay, so here, since this is a multiplication operation, the formula for finding the order of an element is a power n, which will be equal to 1. There, which will be equal to 0. Here a power n, which will be equal to 1. Okay, so now considering the first element. The first element is 1. Okay, so 1 power n. For all the values, this will be equal to 1. So the order will be equal to 1. Next, we are choosing the second element. Second element, what's the second element? That is 3. Okay, the second element is 3. That is a equal to 3. So the formula a power n, we need the value 1. So substitute, that is 3 power 1. That is 3 not equal to 1. So again we are repeating the iteration and we are changing the value 3 power 2, that is equal to 9. Okay, then again changing, this is also not equal to 1. So again we are repeating 3 power 3. 3 power 3 equal to 27. So since this value 27 is exceeding the group consisting of 0 to 9, mod 10. Okay, so we are going to apply mod 10. So you will get 7, which will not equal to 1. So again we are repeating, that is 3 power 4, that is 81. So when applying to mod 10, you will get 1. So if you are getting 1, so we are halting the iterations and the order of the element is 4. I hope you understood this. Okay, right. Now let's do for the next element. 1, 3, 7. The next element is 7. So a power n equal to 1 we need. So a is 7. 7 power 1 equal to 7. So which is not equal to 1. Again we are repeating by changing the n value. So you will get 9 and again 3, 3, and when you are applying n equal to 4, you will get 1. So the order of the element is equal to 4. Similarly, we can perform the order of the element 9 also. So the final value, the order of 1 is 1, order of 3 equal to 4, and order of 7 equal to 4, and order of 9 equal to 2.